Investigation 4. Using deductive and inductive reasoning. There are two basic kinds of reasoning, deductive and inductive. Deductive reasoning bases a conclusion on laws or rules. Inductive reasoning bases a conclusion on an observed pattern. Both types of reasoning can be used to support or justify conclusions. Here's an example. All fruits have seeds. Therefore, an apple is a fruit. The two statements for an argument. The first statement is the premise, the second statement is the conclusion. In deductive reasoning, if the argument is solved, the conclusion is guaranteed. In inductive reasoning, if the argument is solved, the conclusion is supported but not guaranteed. Consider the following examples. Darrell says, according to Newton's first law, which we just studied in science, every object will remain in a uniform motion in a straight line unless compelled to change its state by the action of an external force. So if I kick the ball, it will travel forward at a constant speed until it hits the wall. Aaliyah says, in the past, I've noticed that every time I kick a soccer ball, it travels forward at a constant speed until it hits the wall. The next time I kick a ball, it will keep going until it hits the wall. Now, you and I both know Newton's first law of motion says that if an object is at rest, it will stay at rest. If an object is in motion, it will stay in constant motion. But there's other forces that are exerted on it in terms of the friction of the floor that the ball is in contact with and the gravity pulling it down. So who's right? Darrell's reasoning is deductive because it's based on his knowledge of Newton's first law. So because it's based on the law that says that it won't change its motion, because if a force is applied, that motion is now going in affecting that ball, he's using a law to describe the scenario. That's the deductive reasoning. Aaliyah's reasoning is inductive because it's based on her conclusion of a previous observation. She kicked the ball and it did this once. She thinks that it's going to do it again because she's observed it one time before. So you can see the difference between the two types of reasonings. Even though they're similar, they use a little bit different premise overall. Darrell uses a law and Aaliyah uses an observation. Again, a deductive reasoning type of reasoning is based on a conclusion or law. Inductive reasoning is based on an observed pattern. Let's look at the examples here in numbers 1, 2, and 3. A student has earned a score of 100 on the first 5 math tests. Conclusion: the student will earn a score on the next math test of 100. If it was based on previous scores, then we're talking about inductive reasoning because you're using a previously observed pattern. It's not a rule or law that you're going to get a 100. Number 2, the premise: the measure of 3 angles of a rectangle are 90 degrees. The measure of the 4th angle is 90 degrees. Well, if it's a rectangle, you know that it has 4 sides and it has 4 right triangles. Therefore, you know that that's 90 degrees. That's going to be based on a law. That's deductive reasoning. Number 3, the premise: a number pattern begins 3, 5, 7, 9, 11. The conclusion: the next number in the pattern will be 13. Because you're basing it on the previous growth of each of those differences, this is going to be 13. That's inductive reasoning. Each premise and conclusion above can be written as one sentence. For instance, the second set could be restated as, if the measure of 3 angles of a rectangle are 90, then the measure of the 4th angle is 90. This is called a conditional statement. A conditional statement is a logical statement that can be written in if-then form. So you'll see that these statements are presented in this if-then form to prove them correct, and you'll be able to tell if they are correct based on the reasoning or the type of reasoning that is used, deductive or inductive. A conditional statement is made up of 2 parts, a hypothesis and a conclusion. The hypothesis is the condition. It follows the word if. The conclusion is the judgment. It follows the word then. A conditional statement can be either true or false. Let's take a look at a couple examples at the top of page 255, and then we will complete our lesson today with the investigation practice. For 4, 5, 6, it says, use the given hypothesis to write a true or false conditional statement. Number 4, write a true conditional statement: if you stay in the sun too long, blank. Now, Mr. Shane likes this one because if you stay in the sun too long, then you will get a sunburn if you're like Mr. Shane. My skin doesn't do very well in the beating rays of the sun, so if I stay in the sun too long, I will get a sunburn. Now, that's a true conditional statement because the if hypothesis portion tells us that, well, the sun is this serious force of UV rays, and then the conclusion is a result of being exposed to the sun for too long, usually resulting in a sunburn for Mr. Shane. Number 5 says write a true conditional statement: if a student has a temperature higher than 101 degrees. If it's a conditional statement here and we're using our inductive reasoning based on prior observations. When you've had a temperature higher than 101 degrees, then you would say that you have a fever and you should probably stay home from school. Maybe you might be sick with the flu or something other related to having an increased temperature. Number 6, write a false conditional statement. We want one to be false in this case. If a number is divisible by 5, what would you say? If a number is divisible by 5, then it is a prime number. Well, that's false because all prime numbers aren't divisible by 5. It's obviously easy to write something that's false because you're just trying to get it wrong on purpose. The statement, if a figure has 4 sides, then it is a square, is false. It is not true because a rectangle has 4 sides as well, but a rectangle is not a square. An example that contradicts a statement is called a counterexample. One counterexample is sufficient to show that a statement is false. So anytime you have a false conditional statement, for example in number 6, a counterexample is sometimes what you're going to be asked to provide that proves that it's actually wrong. So if a number is divisible by 5, it's a prime number. Can you think of a prime number that's not divisible by 5 to be a example? Your prime numbers 1, 2, 3, 5, 7, 11. 7 and 11 aren't numbers that are divisible by 5, so that is a counterexample. Numbers 7 and 8 says provide a counterexample for each statement. The sum of a positive number and a negative number is negative. Well, that's false because a positive number and a negative number, depending on what size of the positive number and negative number, could give you a positive number as well. So here we need an example that gives us a positive number when you're adding up these two items, positive and negative. So let's say positive 5 and negative 2. So that would be positive 3. There's a counterexample that proves this wrong. Number 8, if a student is a teenager, then she is 14 years old. Can you provide a counterexample in which a teenager is not 14? How about a teenager that's 13 or 15 or 16 or 17? Hopefully you get that when you have a false conditional statement, you can provide a counterexample to be the opposite to prove that wrong. Let's go ahead and practice the different items that we've learned today. Again, the different types of reasoning, the conditional statements, and then being able to provide a true or false counterexample for a conditional statement. In the investigation practice, letter A and B, it says identify the type of reasoning used. My friend has an allergic reaction when he eats peanuts. Is that based on a rule of law, anybody who eats peanuts, or is that based on previous observations? This would be inductive reasoning because it's based on previous observations. Letter B, if a driver sees a red light, she should stop. Deductive reasoning, because that is a rule of law on how you're supposed to drive. When you get your driver's license, you'll learn to abide by, hey, red light means stop. Letter C and D says use the given hypothesis to write a true or false conditional statement. Write a true conditional statement. If it rains today, fill in the blank. Think about something that might happen because it rains. If you've ever been like Mr. Shane and you played baseball or soccer, something type of event that is outside that needs good weather and it rains, what happens? Well, the game sometimes gets canceled. If it rains today, then we won't go outside for recess, we'll stay inside for recess. Those types of things that would be true based on the weather conditions. Letter D, write a false conditional statement. If x equals 2, then x is negative. Well, 2 is not a negative number, so that's false, right? Very good. Use the diagram to write a counterexample for each statement. Here in this diagram, you've got the largest circle that shows the category of animals. Inside that circle, you have this category of cats, and cats can be female or male, and cats can be Siamese, which is a specific breed of cat. You'll notice that obviously Siamese cats can be male or female, and they fall into that category as well. So we're going to use this diagram to help us with the counterexample for each of these statements. Letter E says, if an animal is a cat, then it is Siamese. Well, we would say that that's false. Cats are animals, but not all cats are Siamese because Siamese is the smallest example in this case of different types of cats. Letter F, all female cats are Siamese. That's also false. Some female cats are not Siamese. You can also say that Siamese cats can be male as well. Hope that helps your understanding. Thanks for completing the investigation practice with me today. God's blessings.